Hi students, today we will be discussing about different types of galaxies. Have you ever wondered about the galaxies? In which galaxy that we are residing? Yeah, we all know that it is the Milky Way. What do we mean by a galaxy? Galaxy is actually a huge collection of gas, dust and billions of stars and their solar systems all held together by gravitational force. We know our galaxy, the Milky Way, has a supermassive black hole in the middle. So when you look up at stars in the night sky, you are actually seeing other stars in our own galaxy. So our solar system is actually only a part of or is actually situated in one of the arms of our own galaxy, the Milky Way. So different types of galaxies come in many different shapes and sizes, ranging from dwarf galaxies with as few as 10 raised to 7 stars to giant galaxies with 10 raised to 12 stars. So their diameters may range from 1000 to 1 lakh parsecs. Edwin Hubble invented a classification of galaxies and he grouped them into 4 classes: spirals, barred spirals, ellipticals and irregular. This classification is still using to describe the galaxies. His original classification of galaxy types was published in 1936 in a book called The Realm of Nebulae. Since then, several people have suggested modifications and additions to his original scheme, but the basic idea of his classification was as it is. His arrangement or classification of galaxy was termed as tuning fork diagram. It is actually he divided different galaxies and picturized it as a tuning fork for the easy understanding of different types of galaxies. And this tuning fork diagram has continued to be useful for astronomers today. So, how many galaxies may be there? It is estimated that there are 170 billion different galaxies in our universe and there may be more. Space in between these galaxies is known as intergalactic space. So we have already said that Edwin Hubble classified the galaxies into 3 main categories: spiral galaxies, elliptical galaxies and irregular galaxies. So we can discuss more about different types of galaxies. First one, we can discuss about spiral galaxies. The 3 main components of a spiral galaxy are bulge, disk and halo. The central portion is known as bulge and the arms may be called as disk and the outer region is known as halo. These are different types of spiral galaxies. So let us discuss about what are the peculiarities of a spiral galaxy. So we have already said that all spiral galaxies have flat rotating disk, central bulges, gas and dust in the disk, and there may be star formation in the spiral arms. Edwin Hubble classified spiral galaxies into normal spiral galaxies and barred spiral galaxies according to the size of their central bulge and the texture of their arms. A large central bulge and broad central arms corresponds to spiral A type galaxies, while a small central bulge and well-defined spiral arms correspond to spiral C type galaxies. So SA galaxies have big central bulges, tightly wound spiral arms, and relatively small amount of interstellar gas. SC category have small bulges, loosely wound spiral arms, and a relatively large amount of gas. SB galaxies are intermediate between SA and SC, and our own galaxy is assumed to be a SB galaxy type. Milky Way is actually a spiral B galaxy. The lower branch of 24 diagram is actually galaxies with the barred spiral galaxies. The B stands for barred. In a barred spiral galaxy, spiral arms wind away from an elongated central bar rather than from the spherical central bulge. We can see the pictures of barred spiral galaxies. So all spiral galaxies have a rotationally flattened disk and it contain moderate amounts of gas and dust. That means there is a chance of a new star formations in spiral type galaxies. Next we are moving on to different types of elliptical galaxies. Actually Hubble classified elliptical galaxies into E0, E2, E5 up to E7 types of ellipticals, and elliptical galaxies actually look roughly egg-shaped and relatively featureless, and all that can usually be detected is only a decrease in surface brightness as one move outward from the center of galaxy. That means center of galaxy is more brighter than the outward surface. Apparent shapes range from almost circular elliptical galaxies to curved elliptical type galaxies. That means he classified E0, E2 type galaxies like perfect circular types, and curved ellipticals are E6, E7 type galaxies. So what are the peculiarities of elliptical galaxies? They contain very little gas and dust, and that gas that is present is very hot and diffuse. As a result, there is no current star formation in elliptical type galaxies, and the stars already seen in elliptical galaxies are old population 2 star stars, unlike other type of spiral galaxies. Also, elliptical galaxies are not rotating rapidly like spiral galaxies. Elliptical galaxies are classified into different types according to how flattened they appear. In short, elliptical galaxies are actually slowly rotating ellipsoids in the sky, and they contain little gas and dust, and therefore no probability for new star formations. They contain only old population stars. Next we can go on to irregular type galaxies. Actually, irregular galaxies tend to contain lots of gas and dust. As a result, it may contain chances of star formation. Star formation is very probable in this type of galaxies. As the name suggests, it has no specific shapes for these galaxies. That means the positions of stars are randomly distributed. Irregular galaxies are given their characteristic irregular, patchy, messy appearance. Examples are large and small magnetic clouds, which are some parsecs away from our own galaxies. These are different types of irregular galaxies. So, from Hubble tuning fork arrangement, we can see different types of galaxies. Actually, it does not show an evolution of galaxy formation, but it only picturizes the different types of galaxies to understand in an easier way. And this type of classification is still used by the astronomers.
the observable universe, each with many millions or billions of individual stars. So which galaxy is our home? Let's take a look at this collection of galaxies. This is called the Virgo supercluster, containing over 100 smaller groups and clusters of galaxies, such as the Virgo cluster and the local group. Now let's zoom in on the local group. This contains more than 50 galaxies, many of which are tiny dwarf galaxies, but some of which are fairly large by galactic standards. The largest of these is called the Andromeda galaxy, which is a spiral galaxy. Around half that size, the next biggest is called the Milky Way galaxy, also a spiral galaxy, and that's our home. It's a pretty typical barred spiral galaxy, containing somewhere between 200 billion and 400 billion stars. It is about 100,000 light-years in diameter, meaning it takes light 100,000 years to travel from one edge to the other, whereas it is only about 1,000 light-years thick. These are estimates, as there are no well-defined edges to the galaxy. It is simply a disk with several arms of varying sizes, surrounded by a halo of stars, with a dense bulge in the middle, most likely harboring a supermassive black hole at the center of its nucleus, just like other large galaxies. About 15% of the visible mass of the Milky Way is in the form of interstellar gas and dust, scattered between all the stars. Some of these stars form groupings called open clusters, such as the Pleiades, which is a few hundred stars bound fairly close together. Beyond the stars in the disk, there are also several objects in more distant orbits called globular clusters. These are dense spherical collections of stars, anywhere from a few 100,000 to a few million, and there are a little more than 150 of them traveling around the halo. These are always filled with population 2 stars, indicating that they are very old, probably forming at the same time as the Milky Way. The Milky Way also has some satellite galaxies, which are smaller galaxies that orbit around it. The most prominent of these are the Small Magellanic Cloud and Large Magellanic Cloud, each around 1/10 the size of the Milky Way and observable from the southern hemisphere. These interact with the Milky Way as they orbit, resulting in disturbances and also exchange of material. Andromeda and the Milky Way are also on paths that will cause them to collide sometime around 4 billion years from now. Simulations show that this will be an incredible event that will take several billion years to play out to completion. Many stars will be ejected, but the end result will likely be a merging to form a larger, more elliptical galaxy that has been dubbed Milkdromeda. So what do we know about the formation of the Milky Way? Well, its rotation provides some information. Stars outside of the bulge move around galactic center with a speed of around 220 kilometers per second. That's astonishingly fast by earthly standards, but even so, it takes stars in the outer areas about 250 million years to go once around. The closer stars are to the center, the less time they take to orbit, just like planets around their sun. In fact, this is the phenomenon that is largely responsible for the formation of the spiral arms in the first place. This is all typical among spiral galaxies, as we can observe by looking at other galaxies in our vicinity. The oldest stars we can see in the Milky Way are very old population 2 stars. So we believe the formation of the Milky Way dates back to that early era of galaxy formation, less than 1 billion years after the Big Bang, whereby a dense region of gas collected to form a system of gravitationally bound stars.
Okay, now go through the video again and again and study well. Okay, bye for now. Thank you.